This is the construction phase of Antwerp Porthouse. It begins from the foundation to concrete and steel pillars and concrete bridge, then to the main steel structure that sits above the pillar, and for the finish, which is the flooring and interlocking the facade to the steel structure. In this week's video, we would like to share the process of construction of two main concrete pillars and the concrete bridge that links two concrete pillars located in the south wing of the existing building and the center void. For the beginning of our presentation, we would like to start with the construction process of two main concrete pillars. Zaha Hadid chose fair-faced concrete as a design concept for the concrete pillar, newly built at the south wing of the existing building. Therefore, general contractor decided to construct the concrete pillar with formwork method. No other structures or elements were used in the construction of the pillar, but self-compelled concrete. When people think of concrete, pretty isn't often the first word that comes to mind. It's great for sidewalks, foundations, and load-bearing structures, but it's thought of as too rough and uneven to have any aesthetic value. However, with advances in architectural technology, a new type of concrete design is created that appeals visually. Then, what is fair-faced concrete? It is a mixed with aesthetic beauty. It's often smoother and lighter than traditional concrete mixes. No other elements or tools are used to hide the concrete wall, but the concrete itself is part of the design element. Fair-faced concrete column has 12 lateral surfaces at different angles. Also, the pillar was divided into 5 parts total as shown in the diagram for easier construction process. 3 systems were used in the phase of pillar construction. They are large area formwork, load-bearing tower, and climbing formwork. Large area formwork is basically using a panel for a formwork. Its benefit is high speed, safety, and simplicity. Using this formwork, it has a high speed on removal and installation due to few parts on the panel. For safety, it could be installed on a ground level with less crane needed. And for simplicity, not many tools are needed to be installed on the floor or wall before pouring the concrete. As the pillar construction is processed vertically with the rugged steel frames, this system is designed for large shoring heights and high loads. It unites high load capacity and safety in every situation, as it has a simple and fast vertical stacking and continuous height adjustment. Also, easy angle changes due to the level of the ground level and unusual layout. This system made the concrete pillar construction process much easier and faster than common speed. This system is worked with the first system, large area formwork, in the construction. The concrete pillar was able to be designed with 12 different lateral area and angles with the large area formwork and climbing formwork. This system helped constructors build very complex structural design with easy adaptation to highly diverse requirements. As we were not able to obtain many different image resources of concrete pillar construction, we decided to use BIM to demonstrate the actual work that took place in our concrete pillar. We tried our best to simulate the different angles the actual pillar has with Google SketchUp.
And from now on, we are going to introduce you about next structure called the bridge. The role of the bridge is to connect infrastructures to withstand load of superstructure and provide space for people to move between two structures. Because the concrete structure is relatively stiff compared to the existing building, the load is spread evenly over the substructure. So the engineers managed to find the way to make the whole structures work together. As a result, they planned to make a double bridge consist of bottom and top bridge girder, Virandil truss, which will be introduced in detail soon, and massive parts. It allows bridge to be as light as possible and also fulfill its role as a support structure. To strengthen the force throughout the interaction of the components, bridge's demolding process was done very quickly by easy unlocking tilting pin system. Support elements have a tilt pin that can be unlocked with a simple hammer tap. As a result, the inner tube of the support automatically lowers 7 mm in relation to the outer tube. It reduced the compressive force in that support and making extra carrying capacity available, making it possible to ignore the deformation under 7 mm. After they finish the design, they evaluate the safety of the structure using the 3D modeling analysis program. They had to construct top girder 4 weeks after the bottom girder's concrete poured. And the important point was whether it would be stable or not when they demold and unlocked the tilting pin. They found some concerned points about excessive deformation, but after iterative adjustments and calculations, they could conclude that there are no dangerous points. There is a steel support truss which supports the superstructure inside the massive part of the top bridge girder. This structure was applied by lifting a prefabricated frame with a crane. The shape is Virandil truss, which is suitable for supporting the front load of about 1,700 tons from the superstructure. Virandil truss is a structure that is made of straight member between the upper and lower chord member, and each joint is made of a fixed connection to utilize the space on the lowest floor of a high-rise building or to receive a lot of force. In the Porthouse, the space was utilized by a staircase inside the truss. So the construction process was like this. After the main columns were complete, bottom girders were constructed continuously after the column. Then, the steel Virandil trusses were installed for 6 superstructure modules. After modules were installed, bridge construction work finished by completing massive parts. These were the contents of infrastructure so far. From next week, we are going to tell you about the superstructure. Thank you for listening.